Imagine standing on a busy street corner in the middle of Guangzhou's evening rush. The air is thick with the rhythmic hum of delivery scooters and the neon glow of storefronts. You tap a button on your phone, and a sleek white Toyota Sienna pulls smoothly to the curb. The door slides open, inviting you in. But as you settle into the back seat, you notice something unsettling. The front seat is completely empty. There is no driver, no safety monitor, just a steering wheel that begins to rotate with a clinical, ghostly precision, navigating through a chaotic sea of pedestrians and cyclists without a second of hesitation. For years, we've treated this scene as a futuristic novelty, a look-what-they're-testing moment that felt safely tucked away in the someday category. We've seen the viral clips of steering wheels spinning themselves and mostly viewed them as expensive, niche experiments. But as you look out the window, you realize it's not just your car. You see another one at the light, then two more turning the corner, all weaving through traffic with the same eerie, calculated calm. That is because the narrative has just shifted from experimental to inevitable. While the world was debating whether we could ever truly trust a machine behind the wheel, Pony AI and Toyota were quietly finalizing an assembly line. They aren't just testing a handful of prototypes anymore. They're rolling out 1,000 of these driverless units this year alone, with a roadmap to flood the streets with 3,000 by 2026. What's even more jarring than the technology itself is the economics. These rides are hitting the pavement at a price point that makes a traditional taxi look like a luxury service, charging as little as 10% of a standard fare. When a crosstown trip costs less than a bottle of water, the world changes fast. We are witnessing the birth of a $40 billion industry, and the driverless future just stopped being a headline and started being a mass-produced reality.
It's a powerful way to start. And honestly, it's the only way to really frame what's happening. Because if you just look at the investment reports or the policy documents, you miss that feeling, that visceral reality of the empty driver's seat.
Get past the headlines and into the machinery of how this is all happening.
Yeah.
And the data, every signal we're seeing suggests that what you call the science fair phase of autonomous driving, that's over.
It is definitively over. We're now in the industrial scaling phase, and that's a completely different ballgame.
That distinction is exactly where I want to spend our time. Because, I think a lot of us, myself included, still have this mental picture of a self-driving car as this incredibly fragile, maybe $1 million piece of lab equipment that gets, confused by a plastic bag blowing across the road.
Right, the classic edge cases that dominated the conversation for a decade.
But what you just described, what's happening on the ground, is something else entirely. We're not talking about a handful of prototypes. We're talking about an assembly line. Not testing, but flooding the streets. So how does a technology make that leap so fast? That usually takes years, if not a decade.
It does. It absolutely does if you're following the traditional playbook.
Yeah.
But what we're seeing here is a fundamentally different approach, it's a different philosophy. To really understand the speed, you have to stop looking just at the car.
Okay.
You have to look at the environment the car operates in. That's where the secret is. We have to talk about the institutional advantage. We have to talk about the smart grid.
Smart grid, that's a term I associate with, the electrical grid. Power lines, you're talking about roads.
For the roads themselves, if you look at how autonomous driving has developed, especially in the West, it's been overwhelmingly vehicle-centric.
Meaning the car has to do all the work.
The underlying philosophy was essentially the world is dumb. The road is just asphalt. The traffic lights are just lights. The other drivers, the pedestrians, they're all unpredictable variables. So the car has to be a solitary genius.
A lone wolf.
It needs a supercomputer in the trunk, array of incredibly expensive sensors, all to process every single pixel of reality in real time and make a prediction. It has to guess.
And guessing takes a huge amount of computational power. And it's prone to error.
Exactly. But the approach that's enabling this massive scale-up is different. It's about vehicle-road cloud integration. That concept is the absolute core of China's new infrastructure initiative. It's not about pouring more concrete. It's about embedding data into the concrete.
Okay, so give me a practical example. Instead of my car's camera trying to figure out if a traffic light is red or green.
The traffic light tells the car it's red. It broadcasts its status directly to the vehicle.
Okay.
That's the CV2X system at its most basic.
All right, let's stop there because that's a huge concept. CV2X. Break that acronym down for us.
It stands for Cellular Vehicle to Everything. And the everything part is the most important word in that phrase.
So not just vehicle to vehicle?
No, that was an earlier iteration of the idea. This is vehicle to everything. The car is talking to other cars, yes, but it's also talking to the infrastructure. V2I, as it's called. The traffic lights, the road signs, the sensors embedded in the road.
So a digital road sign could warn of ice ahead before the car's sensors could even detect it.
And it's also talking to the network V2N, which is the cloud component. And in the future, V2P, vehicle to pedestrian, your smartphone could broadcast your intention to cross the street.
That is a paradigm shift. Let's use a more complex scenario. A blind intersection in a dense city. A human driver, or even a camera-based system, can't see what's coming until they're right at the edge of the building line.
It's a classic danger zone. But with CB2X, the intersection itself becomes an intelligent node. The traffic light is broadcasting, "I will turn red in exactly 4.2 seconds." The camera mounted on the lamppost is broadcasting, "Warning, pedestrian obscured by a delivery truck is approaching the crosswalk."
So the car knows what's around the corner before it gets there.
It knows. It's not guessing based on interpreting pixels. It's receiving definitive, structured data. And that completely changes the processing requirement.
It must slash it. If you're being handed the answers, the car doesn't have to spend all its energy trying to solve the problem from scratch every millisecond.
It's the critical efficiency unlock. It removes so much of the computational burden, so much of the uncertainty from the vehicle's onboard systems. And look, this isn't just a theory on a whiteboard. This is happening.
What's the scale of it?
Well, back in 2021, there were already 28 different enterprises qualified for high-precision mapping. They were building these incredibly detailed centimeter-level maps of the cities. At the same time, you have this massive nationwide rollout of 5G to provide the bandwidth for all this data to stream constantly.
So it's a pincer movement. You're building the digital twin of the city with the maps, and you're building the nervous system to carry the data with 5G.
It's a coordinated, top-down, centralized effort to digitize the physical world for machines to navigate. It's truly breathtaking in its ambition and its execution.
This coordination seems to be the word that keeps coming up. And you can't talk about coordination on this scale without talking about policy. I think for many of us, especially in the tech world, we tend to see government regulation as friction, as something that slows innovation down.
Absolutely.
But in this case, it feels like the government is acting less like a regulator and more like a grand project manager.
It's the visible hand actively shaping and guiding the market. When you read documents like the 14th Five-Year Plan or Made in China 2025, these aren't just aspirational white papers or press releases.
They have teeth.
They have enormous teeth. They're signals that cascade through the entire system. When the central government declares that autonomous driving is a strategic priority, that single decision unlocks billions in state-backed funding. It triggers tax incentives for R&D. It aligns all the local governments to start clearing paths for testing.
So it's a green light for the whole country all at once.
Yes, but it's even more granular and frankly more elegant than just that. There's a specific action they took that's worth highlighting. The national standardization of the taxonomy of driving automation.
You mean the levels? Level 1, level 2, up to level 5, the full self-driving.
Exactly. But it wasn't just defining them in an engineering paper. In 2021, the key ministries, the Ministry of Industry and Information Technology, the Ministry of Transport, they came together and created a single, legally binding national standard for what each level means.
It sounds like bureaucratic paperwork.
It's the opposite. It's the oil that makes the whole engine run smoothly. Because now, every single company, from the smallest startup to the biggest OEM, is working toward the exact same technical specifications. Every insurance underwriter knows precisely what a level 4 system is liable for. Every city planner knows what rules to write for an L4 operational zone.
There's no ambiguity.
None. It eliminates the kind of fragmentation you see in other parts of the world where the rules might be different from one state to the next or even one city to the next. You don't have a situation where a robotaxi is fully legal in Guangzhou, but technically operates in a gray area in Shanghai.
And that kind of certainty must be incredibly valuable for companies looking to invest billions of dollars.
It's everything. And that legal and technical alignment is what enables the next step, the testing ground strategy.
Okay, let's talk about these test zones. Because again, my mental model is a giant empty parking lot with some orange cones.
We have to completely throw that image out. We are talking about entire districts of major cities. Look at Beijing Yuzhuang. It's a massive area. The government has essentially designated it and other zones like it in Shanghai and Guangzhou as a demonstration zone.
That's a sandbox.
A real-world sandbox. They're effectively saying to the companies, in this specific zone, the rules are different. The liability is managed. Go and run your commercial pilots here now.
The phrase commercial pilots is key there, isn't it? They're not just testing if the car can turn left.
No. They're testing the entire business model. They're running real ride-hailing services. They're dealing with actual customers, with payment systems, with rush hour traffic, with, the chaotic ballet of delivery scooters cutting them off.
So they're collecting data not just on the car's performance, but on the product's performance.
It lets companies like Pony AI and Baidu iterate on the product experience at a speed that's impossible anywhere else. They're learning what customers want, what routes are most profitable, how to manage a fleet. They're solving the business problems in parallel with the technology problems.
It's a stunning example of what you called institutional efficacy. When you have the road, the cloud, the policy, and the commercial testing all aligned and moving in the same direction, the friction just evaporates.
You're not just building a car, you're building a habitat for that car to thrive in.
And that habitat is what explains the speed. It's not necessarily that the individual engineers are, 10 times smarter. It's that the system has been engineered to make their job 10 times easier.
The problem they have to solve has been fundamentally simplified by the infrastructure that surrounds them.
Okay, so that's the environment. The smart grid, the top-down policy support, the designated testing grounds, that covers the how of the ecosystem.
Yeah.
But we still need to talk about the car itself. And for me, this is the part of the research that was just staggering, the cost.
It has always been the #1 barrier. For a solid decade, the whole story of robotaxis came with a giant asterisk. The narrative was, this is the future of transportation, but each vehicle costs $200,000 to build.
Right. You can't run a taxi service, a service for the masses, if your primary asset costs more than a small house. It just doesn't work.
The math is impossible. And those early Waymo vehicles, for example, were estimated to cost anywhere from $150,000 to $200,000, largely because of those huge spinning LiDAR arrays and the custom high-power computing stacks. It was a luxury good trying to pretend it was public transit.
But the numbers we're seeing now, I had to double-check them because they look like typos.
But they're very real. We saw the TechNode report on Pony AI slashing the cost of their self-driving hardware and software stack by 70%. But the real jaw-dropper is Baidu's Apollo RT6.
This is their 6th-generation vehicle.
And they announced the manufacturing cost. It's just 250,000 RMB.
Okay, let's put that into dollars for everyone. At current exchange rates, that's about $34,300 US.
Let's just call it $34,000.
It's the price of a normal car. A brand new Toyota Camry or a Honda CR-V that a family would buy.
It's cheaper than many of them. We have officially reached, and in some cases surpassed, price parity between a standard human-driven car and a fully autonomous Level 4 robotaxi.
How is that even possible? I mean, how do you take what used to be $100,000 worth of hyper-specialized sensors and computers and shrink that cost down by 90% or more? Is it just Moore's Law? Or is something else going on?
It's not just one thing, but the biggest factor is the power of an integrated supply chain. And specifically, a concept called the Tier 0.5 supplier model.
Okay, that sounds like industry jargon.
It's a crucial idea. In the old model, the retrofit model, a company like Waymo would buy a finished car off the line, a Chrysler Pacifica minivan. Then they'd take it to their own facility, strip it down, and start bolting their own equipment on. A big sensor rig on the roof, custom computers in the trunk, new wiring everywhere.
It's like buying a suit off the rack and then having a tailor completely tear it apart and remake it.
It's incredibly expensive, it's labor-intensive, and it's never quite as good as something designed for the purpose from the start.
So the Tier 0.5 model is the custom-made suit.
Exactly. The ecosystem has shifted to native integration. Tech companies like Baidu and Pony AI aren't just buying cars anymore. They are co-designing them. They are integrating directly with the OEMs, the big car manufacturers, right on the assembly line.
They're becoming part of the manufacturing process.
A core part. They're working with vehicle platforms that were designed from day one to be autonomous. Mass-produced EV platforms like the Toyota BZ4X or GAC's Aion V. These are electric vehicles, so they already have the massive electrical architecture needed to power a dozen cameras and sensors. The wiring harnesses are built in at the factory. The sensor mounts are part of the chassis design. The computing units are integrated into the dashboard, not stuffed in the trunk.
So they're basically piggybacking on the enormous scale and efficiency of the existing EV industry.
They are drafting directly behind the EV revolution. The cost of batteries has plummeted, the cost of electric motors has plummeted, and now the cost of the key sensors, like LiDAR, has plummeted too.
Right, LiDAR, the spinny thing on the roof that was always the most expensive part.
LiDAR stands for light detection and ranging, and it uses lasers to build a real-time 3D point cloud map of the world. A few years ago, a single high-quality LiDAR unit could cost $75,000.
More than the entire car costs now.
But because of fierce domestic competition and massive mass production, and also a technological shift to what's called solid-state LiDAR, which has no moving parts, the prices just collapsed. A high-end unit might be a few $100s now.
So you can afford to use more of them.
You can afford to blanket the vehicle on them. The latest Pony AI hardware suite, the one that costs 70% less. It has 14 cameras, 9 LiDAR units, and 4 radar units. That level of sensor redundancy was unimaginable at any price point 5 years ago. Now it's just part of the standard bill of materials.
And what about the lifespan of the vehicle itself? A regular consumer car isn't built for the kind of abuse a taxi takes, running 18, 20 hours a day.
That's a huge piece of the economic puzzle. The utilization rate is brutal, but these vehicles are being purpose-built for it. The specs for the new Pony AI units built with Toyota call for a design lifespan of 600,000 kilometers.
600,000 kilometers. It's over 370,000 miles.
And a 10-year operational life. So now let's put the two numbers together. You have a $34,000 upfront cost and a 370,000-mile lifespan.
The cost per mile just drops through the floor.
To a level that a human-driven taxi with fuel, maintenance, and a driver's salary can never, ever compete with. That's how you get to the scenario we started with. A ride that costs less than a bottle of water.
When the asset is that cheap to acquire and that cheap to run, you don't need to charge premium fares to make a profit.
And that's the true disruption. It's not just a better taxi, it's a different category of service. If I can offer a ride for 10% of the traditional cost, I don't just win the existing taxi market, I create a new market. People who would normally take the bus or not make the trip at all now become customers. The entire pie gets bigger.
This cost reduction isn't just a win for one company. It feels like a triumph of the entire industrial ecosystem. You have the chip designers, the sensor manufacturers, the battery makers, the car OEMs, the software companies, all working in this incredibly tight, efficient loop.
It is the industrial engine running at full capacity. And it's what positions the nation to not just participate in, but to dominate this $40 billion future mobility market. The unit economics are just overwhelmingly tilted in one direction right now.
So we've covered the infrastructure, the policy, and now the cost. The 3 pillars that make this possible. Now let's look at the results on the street. The metrics of dominance. And for that, we have to talk about Wuhan. It seems to have become the global epicenter for this revolution.
Yes, Wuhan is the proof of concept for what happens when you put all these pieces together and hit the scale button. We're talking specifically about Baidu's Apollo Go service there.
They've been operating for a while, but what's happened recently?
The scale of the deployment has just exploded. They went from running small, contained pilots to deploying a fleet of 1,000 of their 6th-generation unmanned vehicles in the city just this year, in 2024.
1,000 cars in a single city.
Yes. And the roadmap they've published is to hit 3,000 vehicles in Wuhan by 2026. At that point, it's not a novelty. It's not an experiment you might see once in a while. If you live and work in the service area in Wuhan, these cars are just part of the traffic, part of the urban furniture.
And a key detail here is the term fully unmanned, right? This isn't the old model.
That is the most important detail. For years, driverless always came with that asterisk. Driverless, but with a safety engineer in the front seat, hands hovering over the wheel.
Ready to take over at any moment.
Or driverless. But with a remote operator in a control center watching a live video feed, ready to teleoperate the car if it gets stuck. The Wuhan deployment is one of the largest in the world to remove the in-vehicle safety driver entirely.
So it's just you, the passenger, in an empty car.
Just you and the machine. That's a huge psychological and regulatory hurdle to clear. To get to the point where you, the company, and the government are all confident enough in the system to say, it's on its own.
That is a massive leap. But the data suggests the public is making that leap with them. And what's really interesting to me is that this isn't just a domestic story anymore. We're starting to see a very clear, very deliberate export strategy. You mentioned the partnership with Lyft.
I did, and it's a huge deal that I think flew under the radar for a lot of people. Lyft, the major American ride-sharing company.
One of the two giants in the U.S. market.
The very same. In August of 2025, a partnership was announced. Baidu will supply their autonomous vehicles, which are manufactured by a Chinese OEM, Jiangling Motors, to Lyft.
For use in the U.S.
Not initially. For operations in Europe. Specifically, they're targeting Germany and Britain, with service slated to begin in 2026.
Okay, that's a fascinating combination of players. You have a Chinese technology stack, the hardware and the software powering an American service brand on European roads.
It's a geopolitical headline as much as it is a technology one. It's the clearest signal yet that the entire autonomous stack is now a mature, exportable product. It directly challenges the long-held assumption that self-driving technology is too complex and too regionally specific to work outside its home country.
The idea that a system trained on the streets of Guangzhou couldn't possibly handle, say, the roundabouts in London or the speed of the German Autobahn.
Exactly. This partnership is a direct bet that their system is now robust and adaptable enough to become a global standard. They're not just selling cars, they're selling the entire operating system for future mobility.
But that brings up the big question, the elephant in the room: trust. You can export the technology, but can you export public acceptance? I know many people right here who would be deeply hesitant to get into a car with no driver. Do we have any data on consumer sentiment?
We do, and the numbers show a really stark contrast. One major survey showed a 50% consumer acceptance rate for autonomous driving in China.
50%, okay.
At the same time, the equivalent figure in the United States was just 36%.
That's a huge gap in acceptance. Is it a cultural difference?
I think it's less cultural and more experiential. The simple fact is, the average consumer in China has had far more exposure to semi-autonomous features in their own personal cars.
You mean things like AD systems?
Exactly, advanced driver assistance systems. Because the domestic EV market there is so incredibly hyper-competitive, features that were once high-end luxuries like adaptive cruise control that works in traffic, lane keeping that steers for you, even automated parking, those became standard table stakes features on mainstream cars very early on.
So the average driver has already spent years co-piloting with a machine. They've felt the car steer itself on the highway. They've watched it park itself.
They've built up a baseline of trust in the software over time. So for them, moving from a level 2 or level 3 system in their own car to a level 4 robotaxi isn't this terrifying leap into the unknown. It feels like a natural, incremental upgrade.
There's also this concept I've read about, the mobile third space. It sounds a bit like marketing jargon, but what does it mean in practice?
It's a reframing of what a car is for. For 100 years, a car has been a machine you operate. The focus is on the driver's seat. But if you're not driving, the steering wheel is just wasted space.
The car becomes a room.
A small, private room that moves. It's a third space, after your home and your office. It can be a place to take a video call, to watch a movie, to relax. When you start to view the vehicle as a service you inhabit rather than a tool you control, your desire for automation goes way up.
It turns the commute from dead time, a chore, into productive, useful time.
Or just personal time. And that shifting perspective is a powerful driver of acceptance.
Which brings us to the other side of this utility. We focused heavily on robotaxis, on moving people. But there's a quieter, maybe even bigger revolution happening in moving things.
Logistics. Absolutely. It doesn't get the same flashy headlines as a robotaxi, but in many ways, the business case, the return on investment, is even clearer and more immediate. We're seeing a massive push into what's called autonomous line haul trucking.
These are the big rigs, the semi-trucks on the highway?
The 18-wheelers, yes. Yeah. You have companies like Inceptio Technology and Plus that are already deploying level 3 and even level 4 capable trucks in commercial operation. And the driving force here isn't just technology, it's demographics.
A labor shortage.
A huge one. There are 17 million truck drivers in China, but it's an aging workforce. It's grueling, difficult, often lonely work. Younger generations are not lining up for these jobs. Autonomous technology is seen as a necessary solution to a looming economic problem.
And I imagine there are efficiency gains as well.
A human driver has limits on how many hours they can drive. A machine doesn't. A human driver's fuel efficiency can vary. An autonomous system can optimize acceleration and braking perfectly over a 1,000-mile journey, saving enormous amounts in fuel costs. But where the technology is already fully mature and profitable is in what we call closed-loop environments.
Closed loop meaning controlled areas away from the public.
Exactly. Think ports and mines. There's a company called Waitis, for example. They build and operate fully autonomous dump trucks for use in massive open-pit mines.
Now that's a hostile environment. Dust, mud, extreme weather, no paved roads.
It's incredibly hostile, but it's also predictable. You don't have to worry about a child chasing a ball into the road. The variables are controlled. You just have trucks and rocks. In that environment, the robots can run 24/7. They don't need sleep. They don't take lunch breaks. They see perfectly in fog or dead of night.
It sounds like the perfect incubation chamber for the technology.
Because it generates real profit right now. It proves the durability of the sensors and the hardware in the toughest conditions. And all the learning and data from those mining trucks gets fed back into the wider R&D ecosystem for the passenger cars.
And you see the same logic at play in ports.
Identical logic.
Yeah.
You have autonomous straddle carriers and container transporters moving with robotic, millimeter-level precision in some of the busiest ports in the world. These are the hidden, unglamorous victories that are already paying the bills and maturing the technology stack, completely separate from the public-facing robotaxis.
So when you step back and you look at the whole picture, the robotaxis flooding Wuhan, the autonomous trucks on the highways, the robotic mining rigs in remote provinces, what is the projected value of this entire transformation?
The numbers are, frankly, hard to comprehend. One projection from KPMG estimated that the driverless robotaxi market in China, just that one segment, could reach 1.3 trillion RMB by the year 2030.
1.3 trillion RMB. That's what, nearly 200 billion US dollars?
It's an economy in its own right. And that's just the revenue from the rides themselves. Think of the second-order effects, the disruption. The auto insurance industry gets completely remade. Who do you insure? The algorithm or the passenger?
The real estate market changes. Do you need vast parking garages in the center of the city if the cars are constantly in motion and never need to park there?
The value chain is completely rewritten, and that's why you're seeing billions upon billions of dollars in private and state-backed capital pouring into this sector. The investors see that this isn't just about building a better car, it's about building the infrastructure of the 21st century economy.
It really feels like we're past the point of asking if this will happen. It feels like we're watching an inevitable convergence.
That's the perfect word for it. It's the convergence of those three pillars we've been talking about. You have the road, the state support, the smart infrastructure. You have the car, the manufacturing excellence, the radical cost reduction, and you have the market, the consumer readiness, the massive data sets for training.
When those three things align perfectly,
you exit the experimental phase. You enter the era of mass application.
It really brings me back to that image from the beginning, that empty driver's seat. For so long, that image felt like a ghost story, something unsettling. It represented a loss of human control.
A void.
Yes, a void. But after breaking down the layers of the system, the redundant safety, the incredible efficiency, the economic benefits, it seems like that empty seat isn't a void at all. It's an opportunity.
It represents a fundamental shift in our relationship with mobility. It stops being a task you perform and starts being a utility you consume, like turning on a tap. You don't think about the reservoirs, the pumping stations, the pipes. You just expect clean water to come out.
And this technology promises to make movement, the act of getting from A to B, as seamless, cheap, and reliable as running water.
That is the ultimate goal. And as we survey the global landscape today, it's impossible to ignore that while some regions are still wrestling with the if and how of regulation and public trust, the machine here is already in full motion.
We're looking at a future where mobility is a utility, cheap, ubiquitous, and completely automated. And that future has a Made in China stamp on the engine block.
It's a technological and industrial reality that will define the global economy for the next generation.
A truly fascinating deep dive. Thank you for walking us through the machinery behind the headlines. It's been incredibly insightful.
Pleasure. It's a complex but vital story to understand.
And thank you, our listeners, for coming along for the ride. We'll see you on the next deep dive.